Good evening.
Good evening.
Let me know if you have any questions. Someone just asked if formula sheet was allowed on test number 3. Yes, it is. I'll also respond to the email. I don't know if you still can hear this, but your message was kind of hard to see. I would, if you have any issues about the test, about the what do you call that? About the testing environment, the testing video when you're taking the test. Um, I would, if you still have questions, I would take a pic. I would like have your laptop up and then take a picture of it and then send it to me, or do the responders lockdown check because there's like a practice quiz in there, and then let me know that you sent it there so that we can make sure there are no questions. Someone said, "Are we supposed to remember all the rule problems?" Don't know what you're talking about when you mean rule problems, but you're allowed to have a study sheet. So I would definitely write down whatever I want to remember so I can use it on the test. as far as all the different rules like Pythagorean, quotient, reciprocal, algebra, sum, difference, or whatever, again, I'll write those things down. You should be able to get them pretty succinctly on one piece of paper. But as you use them, hopefully you're remembering some of them. Okay, that makes sense. As long as it's on one piece of paper, it's all good. Uh, Jeffrey, give me an example problem and I'll do it. And you feel free to, you can email me, remind, any way that you can get in contact with me to let me know what the problem is, you can do it. Okay. All right. So we're going to do this. Let me bring up one more thing. I have a problem incoming. Appreciate it to the person that did that. I didn't want to sit on here and not do any problems. Okay, one more thing. I'm bringing up one thing as we are beginning. Yeah. Let's see. Here. No. 19. There's something I forgot. 20. Never find this stuff in. Yeah. Here we go. Yeah, that'll do it right there. All right, so got a problem here. Let's take a look at it. It says, yeah, y'all can see this, I think. Find sine of 2x, cosine of 2x, tan of 2x, if tan of x is equal to negative 3 and x terminates in quadrant 4. So, yep, I'm not on mute, so let's do some work. Draw a picture. We're in quadrant 4, so that means we're down here. So, boom, right triangle, theta's right there. And it says that tangent of x, or theta in this case, tangent of x is equal to negative 3. So that means that tangent of this angle is opposite over adjacent. So that is negative 3. So negative 3 over 1. Now that doesn't necessarily mean that this point here is 1, negative 3. But remember that trig ratios are ratios. So they give us the rate, the how these two lengths compare to each other. All right, so first thing we need is the hypotenuse. So a squared plus b squared is equal to c squared. So a is 1 squared plus b is negative 3 squared is equal to c squared. 1 plus 9 is equal to c squared. So 10 is equal to c squared. So square root of 10 is equal to c. By the way, please let me know if I'm going too fast. Let's see. Rules, trig sheet. Can I go over problems with use these rules? I answered that. Can you go over the identity sign? I need to look at that. Carla, if you could email me that or send me a screenshot, that'd be good. Blake, yes, you will be able to you will be able to use a formula sheet. The test will be open from 12:01 a.m. to 11:59 p.m. Standard time. I'm never going to change those. All right, back to this. Root 10. So square root of 10 is a hypotenuse. Now we know that this square root of 10 can be positive or negative, but because it's the hypotenuse, it's always positive. So here we go. So sine of 2x. So, or 2 theta. We could say 2 theta or 2x. It doesn't really matter here. Now, the issue that we have with that is that we know so we can figure out what the sine of this theta is. We don't know what the sine of 2 times that theta is. We haven't learned that yet, but we have learned some identities. Okay, one of the identities that we've learned is that sine of 2x is equal to 2 times sine of x times cosine of x. So in this case, sine of 2 theta is equal to 2. The sine of, spread it out a little bit. The sine of this angle is negative root 3 over root 10. Or negative 3 over root 10. Normally we would rationalize this denominator, but we will save all of that to the end. Blake, you are 100% welcome. I'll try to remember to send out an email about that too, because I've had that question a couple of times. Yes, formula sheets are allowed. Cosine of x here is 1 over root 10. Okay, so then we do a little bit of algebra. So multiply the tops together. 2 times negative 3 times 1 is negative 6 over. Square root of 10 times square root of 10 is just 10. It's good we didn't rationalize these because it would have made the problem a little bit harder. Simplify this and you get negative 3 over 5. That's the sine of 2 theta. Cosine of 2 theta. Make sure y'all can see this. Again, if you have any issues seeing what I have going on here, definitely let me know. This thing isn't giving me any volume, but that's fine. All right, so the cosine of 2 theta is equal to, there are a few different ways that we can do it. We do the cosine of the sine. We'll do the cosine of the sine. So this is equal to cosine squared theta minus sine squared theta. All right. This just means cosine of theta, quantity squared. So cosine of theta is 1 over root 10 squared minus sine of theta is negative 3 over root 10 squared. Now, a property that you can use on these things, I still feel like I'm going fast, but just tell me if I am, is that if I have A over B, so if I have a fraction squared, that is the numerator squared over the denominator squared. This is supposed to connect. All right, so in this case, this gives us 1 over 10 minus negative 3 squared is 9 over 10, which is equal to negative 8 over 10, which is equal to negative 4 over 5. And the tangent of 2x. The tangent of 2 theta here is equal to 2 tan of theta over 1 minus tangent squared of theta. All right. In our case, this is 2 times. They already told us in the beginning that the tangent of theta is negative. The tangent of x, or tangent of theta, is negative 3 over 1 minus negative 3 squared. 2 times negative 3 is negative 6. 1 minus negative 3 squared is positive 9. 1 minus positive 9 is negative 8. The negatives cancel and I end up with 3 over 4. C is, yes, C is square root of 10. I have that here. You're welcome. Send that. Yeah, 10 is, square root of 10 is C. Okay. This is a good question. This is actually a really, really good question. Good job to whoever asked this. Email me, email me a question. They have not. They have not. Oh, I got another one. Carly, if you're still here, definitely feel free to email me that. Go here. Sorry, Teams is being Teams. Y'all know how that is. Whoa, 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 whoa. Ah, this is a good one. So it says that the question is, lined up, right? All right, so the question is, find the exact value of, I don't need to write that part. Find the exact value of arctan of tangent of 10 pi over 9. Now, believe it or not, this is one of these problems that this is testing what you know. This is testing what you know. It didn't necessarily, you get an answer, but it's not actually giving you the answer. Well, you get an answer, but you don't have to know the middle part of the answer to get the answer. So let's do it. So here's what we know. 10 pi over 9 is, I read it over here. 10 pi over 9 is equal to 9 pi over 9 plus pi over 9. Everybody agrees with that. But we know that 9 pi over 9 simplifies to just pi. That's right here. Oh, good deal. All right, that's just here. So pi over 9, we don't know exactly where that is, but it's going to be around here somewhere. So 10 pi over 9 is going to be around here. And this is pi over 9. Okay. So we know that that's there. We know that when we're finding the arctan of something, it has to be the domain / range of it is from negative pi over 2 to pi over 2. Anything we find the arctan of has to be between from here to here. All right, this is over here. This is out of range. We can't really use that. All right, but we know that the arctangent here is positive. We know that the arctangent of the tangent of 10 pi over 9 is the same thing as the tangent of pi over 9. The tangent of this angle and the tangent of this angle are the same thing. All right, we don't know what that thing is, but we know it's the same thing. So if I take the arctan of this, then I end up, if I get whatever the tangent of this angle is, when I take the arctangent of it, then I get pi over 9. I hope that's helpful. Yes, the inverse trig functions are frustrating, to say the least. Well, they're frustrating, but again, it's looking at what you know. I think the linchpin for this problem is knowing that these two angles, the tangent of these two angles, are the same thing, and they're both positive. So the tangent of this is the same as the tangent of that. You get the same answer. And this is in the range. All right. Got another question here. Let's go to it. Sine of x over 1 plus cosine of x plus 1 over cosine. What? This question is not clear. Sine of x over 1. This is another problem. It's a nice sense. Sine of x over 1 Oh, over 1 plus cosine x. Okay, I think I see it. 7x over 1 plus cosine x. Plus 1 plus cosine x over sine of x is equal to 2 cosecant of x. Carly, this is the problem that you said. Did I write it down correctly? Let me know that if I wrote it down correctly before I start solving. And then I have a 1 plus sine of negative x. All right, Jeffrey, the 1 plus sine of negative x over 1 plus cosecant negative x. The sine of negative x is equal to negative sine of x. Okay, Carly, thank you for letting me know that. So, all right, boom, 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 I answered that question. All right. So, when you're solving problems like this, and I mentioned it on the videos that I have, you're going to look and see which side do you have more to work with. This side has more to work with, so we're going to use this side. All right. We want to get sine x in the denominator. Actually, 2 sine x's in the denominator. So we need to see, what can we do to get that? So we're going to multiply by the... Yes, to add these two things together, they have to have the same denominator. Okay, to add fractions, they have to have the same denominator. So I'm going to multiply. I'm learning how to do this on my Surface, how to go live on my Surface so that I could write a little bit easier. But anyway, what we're going to do is we're going to multiply this one over here. We're going to multiply this by sine of x over sine of x. And this one over here, I'm going to multiply by 1 plus cosine x over 1 plus cosine x. Maybe I should stop being lazy. So I'll just do it like this. Sine of x over sine of x times sine of x over 1 plus cosine x plus 1 plus cosine x over sine of x times 1 plus cosine x over 1 plus cosine x. All right. So when you're solving things like this, can you do 1 plus? Yeah, I'll do that one next, Jeffrey. All right. When you're solving these identities here, you pick one side of the equation and then you make it look like the other. So I don't have to write equals 2 cosine x. 2 cosecant x every time. Let's continue. So, boom. Yeah, we'll use this space over here. So equals left hand. This becomes sine squared of x over sine of x times 1 plus cosine x plus, man, I'm running out of space. 1 plus cosine x. I'm going to just put squared up there because I'm out of space. Sine x 1 plus cosine x. All right. I multiplied the tops and the bottoms. The denominators are the same, so I can add all these together. So this becomes sine squared x. And then I'm going to go ahead and square this. All right. Plus 1 plus 2 cosine x plus cosine squared x all over sine of x times 1 plus cosine x. So I combine these two things together. So when I look at this, one of the things I notice is sine squared x, cosine squared x. Both of these are positive. If I add these together, Pythagorean identity, I get 1. That plus that is 1. 1 plus 1 is 2. So I end up with 2 plus 2 cosine x over sine of x. From there, I factor out a 2 at the top, and I end up with, not sine x. Sine x 1 plus cosine x. All right, so I end up with 2, 1 plus cosine x over sine x, 1 plus cosine x. Because it's multiplication, these two guys can cancel. So I end up with 2 over sine of x. These next steps are just to kind of show you what I'm doing, which is 2 times 1 over sine x, which is 2 cosecant x. This little box that's filled in, when you're doing proofs, that means we're finished. There's also QED we can write on there, which means something in Latin. I forgot what it means, but it means we did what we plan on doing. We're done. Hope that was clear. Good question, Carly. Let's move on to Jeffrey's question. All right. So Jeffrey's question, this is you're welcome. So Jeffrey's question, this is 1 plus sine of negative x. Yes, you can use the approved calculators or the Alex calculator. Over 1 plus cosecant of negative x is equal to negative sine x. Jeffrey, did I write this question correctly? Good deal. All right, let's go to work. So, first thing that we know from what are these identities called? This is called not double angle. This is it's not addition subtraction formula. It's like fundamental identities is what on one sheet that I have calls them. But it's kind of knowing about even and odd functions. With that sine of negative x is equal to negative sine x. So this is actually, and we're gonna pick this side to work on. This is 1 minus sine of x over 1 minus cosecant of x. Because sine of negative x is negative sine x. Similarly, negative cosecant x, cosecant of negative x is negative cosecant x. All right, these functions are odd. So f of negative x is equal to negative f of x. All right, so, well, one of the strategies that when we do this is that we don't like doing proofs with cosecant, secant, and cotangent, because they're not as, I'm sure that there are identities that use them, but we generally don't. We don't use them. We don't learn them. We don't use them. We like to deal with everything with sine, cosine, and tangent. And even tangent, we like to change the sine and cosine if it's going to help us get our proof done. So what we're going to do is we'll spread out a little bit. 1 minus sine of x over 1 minus 1 over sine of x. Cosecant is 1 over sine of x. Can I write the rules down too? What rules? Oh, you can't see my facial expression. I don't know if that's what you're looking for. All right, so let's continue on. So we need the same denominator. We're going to multiply this by this 1 by sine of x over sine of x. And we're not just pulling crap out of nowhere. this is mathematically legal because sine of x over sine of x is equal to 1. So I can multiply anything by 1. So this becomes 1 minus sine of x over sine of x over sine of x minus 1 over sine of x. All right? Keep going. 1 minus sine of x over sine of x minus 1. Ooh, wow. Never had a pencil eat the paper like that before. So we have a numerator, not a numerator. We have a fraction in a fraction. It's called a complex fraction, but we have a singular denominator in the denominator of the whole fraction. We like that because this big bar here, this is a fraction bar. Boom, boom. Oh yeah, we're done with this. All right, this is a big fraction bar, so this is the same thing as 1 minus sine of x divided by sine of x minus 1 over sine of x. All right, if you remember your again, your middle school fraction work, dividing by a fraction is the same thing as multiplying by its reciprocal, or keep change flip, or keep change, whatever one you're used to. So this becomes 1 minus sine of x times sine of x over sine of x minus 1. All right. Now, here's the thing. 1 minus sine of x minus 1. These are the same except for the sine of x is negative here, positive here. 1 is positive here, negative here. Or this is one of those kind of mean tricks that's in trig. These two things are, if you can simplify them because this quantity times negative 1 is that. Okay, let me write over here to the side so you can see it. Negative 1 times 1 minus sine of x. Negative 1 times positive 1 is negative 1. Negative 1 times negative sine of x is plus sine of x. That's sine of x minus 1. I kind of put that in a little thing so you can see that that's what we're going to do here. All right. So these two cancel and become negative 1 over 1. So negative 1 times sine x is equal to negative sine of x. And we are done. I don't know about how y'all feel about doing proofs. But I always like whenever I complete them. It's always good. All right, let's see what we got going on here. Let's see. Proof identity, yes. Calculator, yes. Can I write the rules down too? There are a couple of formula sheets that I could send you, but I'm not writing all the rules. I mean, there are a lot of rules that you use. I'm hoping that while you were doing the problems, you were kind of writing down the rules to become familiar with them. In the homework, we had constant rules. I don't know what you're trying to say there. Sum and difference, algebra, quotient, you can look that up. Quotient, reciprocal, algebra, again, I can send that to you. You can look that up. Yeah, that is a part of the trig identity cheat sheet. Yeah, it is. In the trig identity cheat sheet, I can look one up for you, but honestly, it's easier just for you to Google it. But if you need one, I can send one. That's not a problem. Just ask me to do it. All right, what else we got here? Another question. Also find the sine of 2x, cosine 2x, and tan of 2x when sine x is negative 2. Carly, because it's you, I'll do it. But this is extremely similar to the first problem that I did. So sine of x is equal to negative 2. And we're in Q3. So we're in quadrant 3. We're over here. Sine of x is negative. So x or theta. I use theta for angle. Sine of this angle is negative 2 opposite over adjacent. Wait a minute. Over radical 13. Woo. Root 13. Okay, I was a little confused there. So this is going to be root 13. So the first thing we have to find is this side. This side here is my x value. And then we will be able to go to work. So a squared plus b squared is equal to c squared. Negative 2 squared plus b squared is equal to root 13 squared. 4 plus b squared is equal to 13. B squared is equal to 9. So b is equal to plus or minus 3. But in our case, it will be negative 3 because we are in the third quadrant. Okay. So same thing as always. So sine, y'all can't see that. So sine of 2 theta is equal to 2 sine of theta cosine of theta, which is 2. Sine of theta is negative 2 over root 13. Cosine theta is negative 3 over root 13. Good, we did simplify that, which is 2. The negative cancel. 2 times 2 is 4 times 3 is 12. Root 13 times root 13 is just 13. Sine of 2 theta. Cosine of 2 theta is equal to cosine squared theta minus sine squared theta, which is negative 3 over root 13 squared minus negative 2 over root 13 squared, which is 9 over 13 minus 4 over 13, which is equal to 5 over 13. And tangent of 2 theta is equal to, if I'm not mistaken, it is tangent of theta over 1 minus tan squared theta. Yeah. Is equal to. All right. Make sure I didn't forget it. And I did. 2 tangent of theta is negative 2 over negative 3, which is positive 2 over 3. Over 1 plus 2 over 3 squared. Yeah. All right, so this is 4 over 3 over 1 plus 4 over 9. 1 is the same thing as 9 over 9. So this is equal to 4 over 3 over 9 plus 4 is 13 over 9. All right, if you use the same rule that we just did up at the top as far as multiplying your fractions by reciprocals and all that thing, you get 4 over 3 times 9 over 13. 3, 9 became 3 and 1. So I end up with 12 over 13. Interesting. So divided by 9, 3, 4, 13. Yeah. Yeah, 12 over 13. Boom. Very, very good. That's interesting that those things are the same thing. Okay, I think this problem is done. I'm just looking over it because it looks for sine 2 theta and tan 2 theta to be the same thing. It's kind of weird to me. So I'm just double checking this all. think it's 2 of 3, 4 of 9. Yeah. Yeah. It looks like it might be. It looks like it might be right. Like I said, it's kind of weird. I can't think of a situation where these things are the. Well, these things are kind of weird to me. That's all. I ain't really. Yeah, I ain't really. I'm gonna look at it this some more. But anyway, let's see. Things. Identity. Wow. Okay. Yes, you are welcome. And yes, it's just expanding this out. It's step by step is the way you do these things, and as you do them more, it becomes easier to do them because you see things that you recognize, and you're able to work ahead. Yes, you don't want to try to do it all at one time. You have to do it step by step. As far as going in the wrong direction, that is a part of it. That is a part of it. I guarantee that if you take all the mistakes that this class is made, I've made more than all of y'all to get at put it together have made, over time. But I got better at it because I kept doing it. So as you do it more, it becomes easier to do it more. I mean, I guess that works for most things. So, what other questions do we have? This session is going pretty well, I think. Is everybody good with questions? Anybody have any more? Excellent, Blake. Glad to help. Glad to help. Questions make this a lot more fun. All right, I'll give it a few more minutes. I definitely have my email up, and I have uh, my D2L email up. Oh, I do have questions here. Oh no, this is from. I already answered these. All right. I'll give it like what's this? 46. I'll give it like oh, 47. I'll give it like 3 more minutes, and if no one has any questions, then we'll go ahead and shut this down for the evening. Well, it looks like that might be it for the evening. If no one has any more questions, so if you have anything, let me know. Test opens up in a couple of hours, so make sure you're ready and have a good evening.